this recording available to other people. So today we are going to have Dr. Baker Abdalhaq, but also Dr. Juan Aratia. I'm going to present both of them so you can learn a little bit more about our Saturday Research Academy. As I told you, I'm Dr. Elba Sepulveda. I'm the evaluator and coordinator of the activities for this Saturday Research Academy. And I will let Dr. Aratia first to talk, and then we will have our speaker for the day.
Yes, good morning to everybody and good afternoon to our participant from Russia, all right? We do have also students and mentors coming from Dominican Republic, a lot from Puerto Rico. I invite other colleagues from South America. I don't see it in the list yet, but we got a number over 40 registered for this meeting. Yeah, this meeting will be a constant meeting, really, that we are going to present to the community of high school students and also university students who are interested in STEM disciplines, all right? At this particular time, we have the Dr. Baker Abdalhaq. He is from Palestine. But the nice things about Dr. Baker, he has a degree from Spain. Actually, he has his degree from Universidad, Universidad Autónoma de Barcelona in 2004, a PhD in computer science. So he has been working in artificial intelligence at this particular time at the University of Colorado, Boulder. And it's a very nice place there, but it's a little chilly this morning, all right? So Dr. Baker, you will have access to the chat. So for the student and for the participant, they can ask questions, all right? And we will just get a conversation. So Dr. Baker, he will present us an overview of artificial intelligence and machine learning. So thank you very much, Dr. Baker, for coming to this Fulbright Visiting Scholar series, and you will have a worldwide audience this morning. All right, so you can start your talk.
Okay, good morning or good afternoon, everybody. Okay, thank you for giving me this opportunity to talk with a variety of people. So today I want to introduce AI. Can I have some feedback from the audience of their background? What are the measures they are doing? They are undergraduate, I understood.
Yeah.
I don't know
And
how to make
also
this.
University student, Dr. Baker.
Yeah, the university students are undergraduate, yeah, or graduates.
Yes, no, undergraduate.
Undergraduates, and the majorities are what they are studying.
Oh, different disciplines, really.
Different disciplines.
Yes, it's not. Well, we might have a few very interesting in computer science,
Yeah.
but others are interested in biological science, neuroscience, astronomy, and yeah, so it's a wide area of expertise of this student and some faculty too. So we have really, because this program is just to give them some orientation about what is our discipline, STEM, science, technology, engineer, mathematics, computer science, right? That's the focus of this program, okay? So,
Yeah, it is very interesting to interact with this variety of people, and I don't know if they can raise their hands and give them some way to talk about. I have a question. I want to hear from them how do they perceive uh, these words. What is intelligence? What is intelligence for them? I want to hear before starting my talk how they understand the word intelligence.
anybody can answer that?
I think I'll try. Okay, sorry.
Yes. All right, go ahead.
Yeah, but there's a guy who raised a hand, so I think maybe him.
Yeah.
Yeah, who was talking? Andrea or
Yes, I'm Andrei. Andrew.
Yeah.
Andrew.
Andrew.
Yeah.
Andrew, how you doing, Andrew? Great.
Yeah, I'm okay. How are you?
Yes. Andrew is from Russia.
Yeah. I'm from Russia, from Moscow.
Yes. What do you understand about artificial intelligence?
Not artificial.
Yes.
The word intelligence in general. What does that mean for you?
I think we should separate the emotions and calculating, like math. Is different because we can compare the intelligence like solving the problem, math or physics. It's okay, but it's not about that. It's not all about that. Some about intelligence in human. It's about emotions. It's about how we see the world, how we can compare some different stuff, and how we can explore it and understand new things, what we didn't know before it. And today, computers can do that. Maybe in future, but right now it's we call it the computer intelligence, and but it's not really can learn.
Mm-hmm.
It's the computer can learn in a very sorry, my English isn't so great. Yes, so it's hard to express. It's so little like I don't know how to say it.
Yeah, so you
but
are
that's
saying that the computer intelligence is not the same as human intelligence.
Yeah, it's very limited. It's very
Yeah,
limited for his learning.
It is limited on learning. Human intelligence is discovering and emotional intelligence, how we perceive the world.
Yes.
Are you
and how we can learn new things, because this is the most important thing, because the child doesn't know much about the world and isn't much intelligence. But as we grow, we understand new things and we learn new things. Computer can't do that. He can do only what we can program, even if he learns something, but it's very limited to in what situation he is doing that.
okay?
Yeah, so that's my answer.
Yeah, thank you.
Wait.
And another answer? Anybody wants to say something? Carlos?
Yes, can you hear me well?
Yes.
So I believe that intelligence is like the ability to be able to apply or execute certain skills or things that were learned past. But I think that it could be contrary to wisdom, in the way that wisdom is in sort of knowledge that we already have because we acquired intelligence from another situation, if you understand what I'm saying.
Not quite. You are, yeah, you are differentiating between wisdom and intelligence, or what?
Yes, wisdom, between wisdom and intelligence. That intelligence is what we are able to learn either from executing an activity or from reading, for example, while wisdom can be more of something that we learned because we did already. We have already had a past experience with what we are talking about.
Perfect. So yeah, we use our past experience and utilize it to learn new things or to do something. Is this is we can what you call this, intelligence or wisdom?
I think that personally, I think it would be wisdom.
Okay. Experience maybe, or, okay, we'll discuss this now. Okay, other anybody wants to, yeah, Afanseva, yeah, please go ahead.
Hello,
Hi.
Yes,
how can you hear me?
Yeah, yes.
Hello, I have a different opinion. I think that intelligence is ability to solve problems. There are different levels of intelligence, I know, and there are weak and strong. And weak intelligence works with algorithms.
Mhm. Yeah, it is the ability to solve problem, is we can call it intelligence. And there are two types of intelligence, weak and strong. Yeah, yeah. These are terms in the field. Yanira Nunez.
For me, intelligence can be defined in so many ways, like the capacity for emotional knowledge, reasoning, critical thinking, problem solving, and creativity. To sum up all that, I think intelligence can be defined like the ability to acquire and apply knowledge and skills.
So critical thinking is one of the human intelligence, and it is hard to do, maybe. Yeah. Yeah, okay. Yeah. I don't know if we can give everybody yeah, the opportunity to talk. Last one or two, if somebody wants to talk. We had some. I had a good feedback. I know now more my audience, and of course great people I have here. So yeah, okay. The second question. Can machines, we start to talk about it now when we had some feedback from you. Do really machines, can machines be intelligent? Do they express intelligence like humans, or another type of intelligence? I don't know, this question is philosophical, maybe, and a lot of people tried to answer this, and philosophers to answer this question. A very fast survey I will do now. I think you have the you can raise your hands if somebody believes that machines can express intelligence or can be intelligent, raise your hand.
Yeah.
Okay. Who didn't raise their hands? They believe that no, machines can't be intelligent. I'm not saying about competing human or be more intelligent or as intelligent as the humans. I mean just intelligent. We didn't define, we started defining intelligent now, but we didn't go deeply in defining it. But yeah, okay, your opinion, I want to. 13 out of 43. So the majority believes that no,
Yes.
machines can't be that intelligent. Okay, let's see what dictionaries, how dictionaries define intelligence. Someone's intelligence is their ability to understand and learn things. So they define this particular definition, intelligence as understanding. Okay, it is something need to be defined, understanding, and learn things. We know how we learn every day, and we know what is learning. Okay. Intelligence is the ability to think and understand instead of doing things by instinct or automatically. Is thinking and understanding, two words that are also need to be defined. But this gives us that it is not automatic. It is, yeah, what computers do is are very good in is automatic things. They repeat the instructions perfectly. Can these machines be intelligent? Intelligent is not repeating things or predefined things. It is thinking and understanding. What is thinking then? They both say that intelligence include thinking. Thinking is activity of using your brain to consider a problem or to create an idea. Then thinking, as some of you defined, is considering problems, solving problems, dealing with problems, and create an idea, create new things. But the definition here is using your brain. Thinking is using your brain. So we know what is the brain, how the brain is working. Exactly, we do not know how, but we try to. I think some of you are working in that to understand how our brain is working and how our brains thinks. Okay. Then we can conclude here that the ability to learn, understand, solve problems, and make decisions. We can talk about these particular activities: learn, understand, solve problems, make decisions. Maybe the make decisions and solve problems more obvious things to talk about, but understanding and learning are important part of intelligence. So making decisions is, we have some alternatives and we choose one of them. Solving problems, we have something that we don't know its answer, and we can find the answer. Once we have the answer, then it is solved. But what is understanding and learning? Is more complicated to talk about. We'll talk how computers may understand and may learn. Okay, the debate about the intelligence and if machines can be intelligent or not started from, sorry. Okay, it started from the 50s, from the beginning of the computers. An important paper that was written in the 50s by Alan Turing, the English mathematician. I think we can find in the literature, in the novels about the intelligent machines and things like that. And I think the word robot from the Czech language was one of the words that started to be used before computers in the literature, in the novels, of creating some creatures or some machines that are like humans. So yeah, it is this debate was started before computer, but now I'm talking about in the scientific way, dealing with it in the scientific way. It started in the 50s because in the 50s the computers was in their beginning, and even the computers in some languages was called electronic brains. So it is the beginning that when humans start making computers, it was thought that we are doing a brain. Alan Turing is in his paper Computing Machinery and Intelligence asked these questions. Is there thought without experience? Some of you was talking about experience and the importance of experience in intelligence. Is there mind without communication? Is there language without living? Is there intelligence without life? Very philosophical questions, and they have all maybe similar answers. Turing, to answer these questions, but this test suggested this test to trying to answer if the machine is intelligent or not. Can machine be intelligent or not? By what we call behavioral way. So if something behaves as intelligent, then it is intelligent. This is the idea about his test. It's called Turing imitation game. We can make a test. Let me we put something in the box, the idea, we put the brain in the box and deal with it as a black box but we can know how it reacts on things. If it reacts like intelligent being or human, so then it is intelligent. This is the idea about the test. The test is in two phases. The first phase is we need distant communication, chat bot or chat messenger or something like that. We have, this is the one who makes the test. We have a man and a woman. This one tries, using the only chat, tries to know who is the woman and who is the man from this. The man pretends to be a woman, tries to convince this one that he is a woman, not a man. We repeat the tests and we will have some statistics. How many times this one discovers who is the man and who is the woman. This is the first phase. So we will have some statistics, some numbers that say that there is some percentage that this one will discover who is the man and who is the woman. The next phase, instead of the man, we put a computer with a program. If the statistics, and we repeat the same statistics, if we have, you know, we have to here, then we have two set of numbers, and we try to see statistically if these numbers are drawn from the same distribution or not. If they have the same mean or not, we can use maybe chi-square or something like that. So if the algorithm give us the same numbers, success numbers, as the human, then we can say that this machine is as intelligent as computer. So this was in the 50s, and I think he predicted that in 2000 machines will have maybe 30% or 20%, I don't remember the number, of success or behaves like a human in some way. My questions for you, I think all of you know what is the smartphones with their Siri or Google programs. Do they behave like human? And it is similar to this one. We can make this test with our phones now, these days. And even with using this, we can talk with them, not only chatting. This one was chatting. Do they can we say that they are intelligent, or to what extent they are like humans?
I'm sorry, we have two people that want to talk or
Yeah.
to answer some of your questions.
Okay, yeah, I'm happy to listen to them. Roberto?
Roberto, yes. Go ahead.
I think he just forgot to down his hand.
Okay. Okay. So yeah, if somebody want to say something, I'm happy to listen and discuss. I forgot to say that anytime you can stop me. Maybe my language is not you can't understand something, or anytime you can stop me. Carlos.
Well, I think virtual assistants like Siri, for example, or Amazon Alexa and Google Assistant and all the other ones that there are, they aren't really intelligent, or they aren't, they're just programmed to answer a certain dialogue and not to be able to strike up a conversation with someone, or to basically strike up a conversation. It's mostly just programming to answer questions and things that are already, that is common to be asked.
Yeah. So yeah, Andrea.
Doesn't matter. I think it's not the right question, because it's not important how it is right now, but it's important what it was like 5 years ago. And the change is huge in assistance, because 5 years ago it handled nothing. Today you can talk with it. 5 years later, you wouldn't understand the difference between human and real human. And the problem is that in the end, like 100 years from now, 50 years from now, the computer will not be limited to his power. Although humans will not have new brain. We still have the same brain. We still have the same amount of power, our intelligence power, but computer will be evolving by years. And this is a problem.
This is this is a lot of movies and novels was talking about. Do the computers be more intelligent than people? We can see that computers are faster than us in doing mathematics or calculations, let's say, not mathematics.
Not only that, but for example, deep fakes, when today you can just switch the face or something, post and name. It's moving toward that. So I think it's not just fantastic, it's moving.
We can, the chatbots, for example, how long you can you know that the chatbot is a robot, not a human, from the beginning, or you need some time to know this chat? You know what's the chatbots? A lot of companies make chatbots to help you set up your machines or things and make some services. How long can you? They sometimes, do you know that this is a bot from the beginning, or sometimes you believe, okay, maybe some human is there talking with me? Marisol.
Yes, hello, can you hear me?
Yes, of course.
Thank you. Well, what I'm thinking is that, yes, artificial intelligence has come very far, but they will never be able to have that human connection between us, which basically gives us a big difference, which is why we can't really communicate with them like as a friend or as family. Yes, they are intelligent, but they will never come to the same sense as us because we're humans and they're machines.
Amalia?
So as Marisol said, humans, we have an emotion. We have emotion, so we connect with people. Machines can do that, so they just respond to commands. We as humans think a little bit more, and like we experience things differently, and we know how people can experience them too. So we respond as like thinking of how we would do it, or how we experience that thing, or how we would do things differently. Machines just respond to commands and what other humans program them to do and to say.
Abraham?
Yeah, I was also gonna make some of that points. We humans make machines intelligent as we want them to be. Um, Basically, we are making the programs, and how much programming you put him, much the AI learns. So we basically basically the AI starts like with no sort of knowledge or anything, and by programming and commands we can teach it what to do, what to answer. We can teach it what is his purpose.
Yeah. Okay. Afanseva?
Thank you. Can you hear me?
Yes.
I think their behavior is algorithmic, man-made. This is weak intelligence, and it seems to me that the word intelligence is not entirely correct in this case, based on what we mean by intelligence. But I think that the human brain is like a machine, and in the future, humanity will be able to create an analog that will be able to create something new. At the moment, this is such a difficult question on the verge of fantasy. In any case, the unequalness of a person is that he has experience. But can we give experience to the machine? If a person does this, it will be amazing, and it will be something it's yes, it's difficult question.
Yeah, okay, yeah. I know the questions that I'm asking have no clear answers. So I'm trying to make you think about it only. So I see that time is short. So I'll go faster now to tell you what computers are now or can do now. So yeah, and very quickly I said some people try to say no, that this is not intelligence. The imitation tests of Alan Turing is not does not mean that this machine understand. It can behave like humans in some way, but it is not intelligence. His thoughts. He says that if I am inside a closed room, and all I have, I can get some written thing from as input from outside, and the one who is outside can't see me or know what is happening inside. And if I have some Chinese, I don't understand Chinese, but I can have some Chinese written on a paper, and I can look up what that means, and then look up what the answer would be in Chinese and what is in the as output. Have this input written, and I give the output to the one who is outside. Can ask me some questions in Chinese, and I will give them the answer also in Chinese, but I don't understand that Chinese. This is the saying that this man inside the room and do not understand Chinese, but this system will, of course, we have this data information about everything, and I can have a time to find the answer and give it without understanding what is written here and what is going out. The system can understand Chinese. If I test this system, it can understand Chinese, but the parts of the system do not. Some people claim that this is not intelligence, but others say that even if the parts are not intelligent, but the system can be intelligent. And this is even in our brains. One cell in our neurons in one cell can't make or express the intelligence that we do. No. So it is emergence of the complexity of the system. So the parts are not intelligent, but the system can express intelligence. This is also a philosophical answer to this. Okay, let me maybe I'll skip this part. The intelligence started, or okay. No, I'll talk about this. It is the part of intelligence that we can we know today as AI. First part is logical approach to AI. We can look at intelligence as we can use logic, true and false expressions, and all of kind, or not all kind of these things in the logic, as to make computers be logical, or express some logic. This was from the 50s also. Noel, Simon, they talked about the logical. They were theorist program. They tried to make this program. The program can prove mathematical theorems using logic. So we have a theorem in mathematics, and we can start from the axioms and the propositions and try to. We have a set of non-facts maybe, or non-rules, and apply these rules to the axioms and propositions, and try to see if these are true or not, or try to find a proof that this statement is true. This can be done by computers. So computers can prove mathematical theorems, and we have programs that can help us in that. So this is the idea, starting from a status, facts, knowledge, some knowledge, and we have some rules. We apply these rules to drive another facts. Very simple example in textbooks you can find that. For example, the fact that all humans dies, and I am a human, so I will die. So this is we have facts, rules, and we drive another conclusion from these rules. So this can be done in an automatic way. In 58, a hypothetical advice taker was by McCarthy, the one who started the word AI. This advice taker is to accept the new axioms about the environment and reason with them without being programmed. This is the idea. What I said now, we have some axioms, some facts, some rules. We apply things, so it will give us about the environment advice. Another example you can find in the textbooks about do I if the weather is raining, so take with you the umbrella, for example. This is a simple advice you can program. The idea here is not to give the answers to computer. The computer will find the answers using some rules, logical rules. So I don't put all the answers in the program. I only put some facts, or the facts can be driven from the environment, and I only put the rules of logic that we all know. This is the idea. The new idea is separating knowledge from reasoning. So the reasoning is a process that we know. It is the same process, whatever you are doing. So all the reasoning is the same thing. You can we can make it in symbols in mathematics. And the knowledge is other thing. So this is the idea. This is the the idea of expert systems. The expert systems are there and they are working. So we can. This is one part of the AI that works in AI. How to get the knowledge from people, from experts, not anyone, from experts, and create an expert system that can help novices or new people in doing this, and on working in some situations. Okay. The idea was programmed in a program called General Problem Solver. It is a universal problem solver machine. You give situations and rules, and it applies these rules on the situation to drive a solution. So this is some of you. I forgot the name. Yeah, it is the weak intelligence. It is, can we make a program that can solve any problem? This is what the idea, the 61. Any problem can be solved by giving the computer these axioms and facts and the rules, and applying these rules. We start from the situation. We go to other situation until we reach the desired goal or the situation. It is, we can imagine this as a graph. We start from a node, and we go from this node to other nodes by applying rules. So okay, it was successful on very small or controlled situations. It is it can solve, for example, it can play chess, for example. We have the chess. We start from setting of the chessboard, and we have the rules of the chess, and we have a goal is checkmate, to win the game, and we go from one situation to other situation. The computer needs to we have many options to play, to do many moves to do, and the computer need to choose one or the best move, the move that make you win. So you can imagine how many alternatives that we need to choose from. So this is the problem of this approach, is the combinatorial explosion. A lot of when this idea failed to be applied on a real problems, it is factorial function. If you add another, anytime you add another maybe rule or another fact, or the alternatives will be, yeah, exponentially, or not exponentially, more than exponentially, factorially you explode, or it will be very big numbers, yeah, or alternatives. So it failed. Okay, we talked about the knowledge-based systems, these systems that we can put the knowledge, and we have some successful examples on that. I'll skip it. In the 80s, some mycin, for example, one of the known blood infection. It helps doctors in blood infection. Do I have time, or
well, I think
Yes.
yeah, you can maybe just finish, because
Yeah.
the student, they had to work during the morning, and
Okay.
and I would like to have about just a few minutes just to
Okay. Okay.
to explain
yeah.
why we are doing this. Okay.
Yeah. So yeah, yeah, I'm trying to say that we have a lot of algorithms and approaches that can give the computer some experience or some intelligence, can express in a behavioral definition, as we defined, some intelligence, and it can learn, for example, and can find new things, but in a controlled environment. It is not the general intelligence, but we can use these ideas to find new knowledge. For example, I'm now working with here in Colorado on trying to on classification, we have in CERN, in particle physics, we have some data, and a lot of data, and we want to discover things from this data, and we can apply the intelligent algorithms on this data to find new things that we do not know. So the computer will discover for us, will find for us things. You can, a lot of you have heard about deep learning, and it can recognize patterns. Sometimes in some data, it can find patterns that we do not know. In medicine, in physics, in astronomy, in engineering, a lot of things. So in the learning can be in 3 ways. either supervised or non-supervised or enforced learning. So supervised learning is when you give an example. We try to make things look, we learn from humans, how humans learn, and then we apply it to computers. We give examples to the computer. We have data, we call it features about something, about, for example, some kind of plants, the features of these plants, and we know the classification of this plants. So the algorithms try to find what is the pattern in the feature that give us the right classification. Not always true, correct, but it gives a good precision. So it learns from the pattern. Then we apply the same idea or give the features without giving the classification, and it applies the same patterns to find a new plant, what the classification of this new plant. So this is one way. Other way, we give the computer the data, or the algorithm the data, that it tries to find if there is anything can be classified as a pattern. So it tries to find some patterns. Then enforced learning is used, for example, in forecasting. It tries to classify things or to predict something. For example, predicting the weather. And if the prediction is good, then the parameters that the algorithm has are good, so we enforce them. If the prediction is not correct, it tries to change something inside the algorithm. So yeah, so to do that, we have the evolutionary computation and swarm intelligence. It tries to use the Darwinian evolutionary ideas to find the patterns. The swarm intelligence depends on how ant colony, for example, as we say that the ants, each ant is not intelligent, it acts on some very simple rules, but the ant colony as a whole expresses intelligence. They can find the shortest path, for example. So we can apply it for solving problems. The same idea as ant do. So we try to find things from biology, apply it in computers to express some intelligence, not only from human beings. The neural networks, the big word now these days, it started from the 40s. It tries to make a model, mathematical model of the brain. The neural networks that I use are, compared to the human brain, are very small, so they can be compared to a worm brain, and they can find a lot of patterns and can solve a lot of problems, even with few neurons. So the idea of the neural networks is simulation of the human brain, neurons, in mathematics. I will not go into the details. So this is the idea. We have the neuron, and we try to find a mathematical model of the neuron. It is something like regression, finding the best function. But adding things together will be complicated, as the emergence of the intelligence from things that are not intelligent, from things that are simple. But adding simple things together we can it creates the intelligence. Okay, this is in short words what is machine learning. Machine learning, we have labels and features of the bird, for example, or this picture, and the machine tries to learn why this is a bird because of some maybe numbers there. Why this is a dog, some other numbers. So then we adjust this machine. We adjust some numbers only, a lot of numbers actually, to make this model predicts pictures that we don't know what is it. So it will find the pattern. Okay, so I'll stop here. Any questions? I'm ready if somebody wants to ask
Well,
me.
first of all, Berker, I really appreciate your coming to this group, and I would like to explain to the audience why we are doing this. You see, artificial intelligence is a field that, like Berker explained, right, in the 50s came up. But we didn't have the technology in the 50s. The computer we had in the 50s, you see, were huge room, you see, that now are equal to what you had in your hand. It's like a mobile phone, right? So the technology, we didn't have that. We had the theory, we had everything. We developed many things. I'm part of that because I was born in 1948. Okay, so my education and everything was focused in this area. So, but right now, you see, the explosion, for instance, in medicine, what you see the application of what we can do in medicine, but not by scientists, not by electrical engineers, by MDs with PhD. So they are doing tremendous advances in cancer and many other areas, you see. So that is important. Artificial intelligence is important to be in the curriculum of almost everybody. I'm working here in the United States for artificial intelligence for all, okay? Even the kindergarten student, you see, for the new generation. So because this is going to be a revolution, it's going to be a revolution. And now we compare human with machine, but of course, you see, if we can put all this very sophisticated algorithm into a machine and we can process huge amount of data, of course, the machine, you see, will go beyond what the human can do, right? Doesn't mean that one is better than the other is not good. You see, we have capabilities. You see, we don't really know exactly how, you see, the brain works. We are just learning this time how it works. So, and the work in computer science has been just going slow, but now we have this tremendous, you see, tremendous opportunity. And that's the reason why, you see, we put this kind of talk for the general public. These students, they are going to do the work, probably, the generation of the revolution in artificial intelligence and in different fields. You see, today, you see, in astronomy, for instance, there is so much information out there, but there is, you see, there is not enough people just there. They can really manage the information. So all this machine learning stuff, okay, artificial intelligence based, they are discovering new horizons in knowledge, and that's the reason why we are doing this. You see, is for the next generation and we will just have a tremendous growth. We will finish this because you see the next talk is going to be the brain. I had another Fulbright visiting scholar who came to Puerto Rico in 2015, and she is in Norway now, and she will give us a tour, you see, in the brain. What's there in the brain not from a computer science point of view, but from a neuroscience scientist. And that you will see what is going on in the brain, all right? So I thank you, everybody who has been part of this.
And please don't go.
we would like to, you see, to go back to Elba, because we need to evaluate this, okay? And we would like to have your feedback. It's very short and she will explain. So thank you very much to the speaker. Thank you very much to the audience. And we will see you next time, but Elba will finish. Thank you much. Take care.
Yes, thank you so much for all to be here, and especially for our speaker, because this Saturday Research Academy is enriched by this talk. And it was a very rich conversation starting about artificial intelligence. This is not the last, but we are gonna have more. Please fill the surveys that I put on the chat. It is very important for us to fill the participant survey and the feedback conference survey, please. We need them for the report. These activities are possible because of the Citizen Diplomacy Action Fund. I'm going to share my screen so you can have, I believe that you are looking at my screen right now. Is it a presentation? What you are looking for?
Yes.
Okay, yeah, yes. And this is about the conference that we had today. My next slide is about both of the feedback. Also, I want to thank our sponsors, that is Scientific Foundation, that's from the Caribbean, Dr. Juan Aratia, who is the director of this initiative, had this wonderful idea of sending a proposal to Citizen Diplomacy Action Fund, and we are having this Saturday Research Academy thanks to that. It is very important if you go to this website. We are going to have more conferences going on every Saturday. Thanks for all for filling the survey. And I want to acknowledge that we have people all over the world here, from Russia, from Dominican Republic, Puerto Rico, United States, and many other places. We are very thankful for your participation here. And we have our next presentation. I know that Dr. Aratia mentioned that, but I just want to acknowledge that Dr. Maria Alme is going to be on December 4, and she's going to talk about learning and living with the brain. We have a Zoom link for registration that you can fill out. You can go to Scientific Caribbean Foundation from Puerto Rico, link that I gave you before, to fill out that. Also, we are going to provide today a certificate that for your attendance here. So you can just make a screenshot and you can add that to your portfolio. So this is something that we are going to provide for each one of the talks or conference that we are going to have on Saturday. Thank you so much for being here, and have a wonderful weekend. Dr. Aratia, do you want to say something more?
Elba, remember the group photo. Please ask the audience?
It's
Yes.
gonna be very difficult to make the group photo. We have a video of the whole
Yeah.
team. I already made some photos
Yeah.
because they're large. This group is about 45 people, and they will not fit into only one screen. But we can try to do it.
We can try just one or two screen or three, maybe. We will just fit everybody. Right.
Yes.
Let's try that. But we
So
need
I'm going to.
we need to see your faces, guys. Everybody. Okay. Yes. Let's see. We see the faces.
Okay. I need to stop sharing my screen to be able to do that. Okay.
Okay. Great.
Thank
you very
you.
much. Thank you very much.
Thank you so much.
Yes. Right. Okay. Yes. Let's try to see the faces, everybody. Yeah. Yeah, we are seeing the faces. Yeah. Maybe you can. Great. Yeah. Are you? Yeah, we got almost everybody there in their video. Yeah. Elva, are you trying to get it?
I am in the last one.
Okay.
Yeah, because we have so many people here.
Yes.
Right. And I will thank you all again. I finished all the photos. Thank you
Yes.
so much, all of you, for being here. Remember that we are gonna be presenting more every Saturday. And thank you, Dr. Aratia, for this initiative. And remember that I am Dr. Elba Sepulveda, and I will be moderating your Saturdays. Okay.
Perfect.
Thank you.
Thank you
Thank you
much.
so much.
Okay, take care, guys. Take care. Go back to your Saturday Research Academy. Yeah. Elba, are we going to talk, Elba?
Yes, we have a question here about where are we going to find the recording? Yes, the recording is going to be available at the Scientific Caribbean Foundation page. Yes, I'm going to write down the URL. So it is not going to be available today, but it will be available during the next week. Okay. Thank you so much for asking questions and participate, and for your participation here. Thank you.
Yeah. Yes. Good.
And if you want to stay, you can stay. I'm gonna stop recording.
Yes. Perfect. Yeah. Yeah. Recording stop. Yeah.